As we have logical and physical backups, we have logical and physical replication. Logical replication we have starting from Postgres 10, and it is still not fully functioning. It works, but there are some more things that developers must do for it. And physical replication is quite old, quite mature. What is, I will skip some not so necessary slides. It looks very similar to backups. You just make your backup, physical backup, and then you start the server. But in recovery conf, you specify that this server must work in standby mode. Just one line, standby equals on. And this indicates that when you start up your standby server, it will try to get more and more WAL records and apply it to this database. So it doesn't become separate instance, it just loops in recovery mode. So if you have just a picture, you run this server, you can specify that this server will connect to primary server and get WAL records from it by replication protocol. So
the direction is pull replication or push replication?
Excuse me?
In SQL, we came from the SQL area. In Microsoft SQL, there are two ways to make replication. Two kinds of replication. Pull replication from the publisher to the subscriber, or push replication from the subscriber pull from the subscriber's pools, or to push from the publishers to the subscriber. Here is pull or
this is not publisher-subscriber model. Here is primary and standby, or master and replica. So replica connects to master and retrieve. No, I think that not retrieve. It's like push. Yes, because when your primary server generates WAL records, it gives it through the replication protocol to the replica, and the replica or standby server continuously replay these WAL records, and so we have two servers almost identical, binary identical. This is how replication works. You may use it along with your WAL archive. For example, if something went wrong with your network between the servers, standby servers still can get WAL records from archive as an alternative source of WAL records. And when it can reestablish connection to primary server, it switches automatically to streaming WAL records by replication protocol. Well, so you have the servers. You can use standby server to perform queries. You can run selects on it. So you can use several replicas and run, say, reports on them. But you cannot use standby server to change any data. because standby server cannot generate its own wall records. It just replaces wall records that it gets from the primary server.
So what happens if you need to fail over?
When you need to failover, let me find the slides. You just instruct your standby server, you promote it to normal server, and you switch your application somehow to this new server. And you can continue to work with standby server. And then when then you can reconnect your old primary server as a new standby server to like this, bring it back replication. It's slightly complicated because if primary server crashes, you have no guarantees that all records already were shipped to your standby server. So they can diverge at some point, and one server may have some wall records and another may have another set of wall records. And in this case, you can use pgRewind utility to say rewind your old primary server to the point of convergence, and then you can restore it. Well. How you can use it? You can use several replicas, for example, for load balancing. Postgres doesn't contain any load balancing tool, so you must use some third-party tools, HA proxy, for example, or something like that.
But every standby can be read-only?
Yes, standby is read-only. It cannot change anything. You can use Synchronous replication. It's like Synchronous mode when your commit command waits until all necessary data is flushed to disk. And in this case, your commit will wait until your data will be sent to your standby server, and standby server acknowledges that it received this information. So in this case, your performance is very poor because you need to wait for network, but reliability is great because you have at least two servers with your data. So if something went wrong with one of your servers, you always have another copy of your data. You can use cascading replication in Postgres. What is the problem? If you have one primary server and several standbys, you must have very broad network to send this data to each of replicas, and it somehow loads primary server because it must maintain several wall center processes. So you can set up cascading replication in which primary server send wall records to one standby, and this standby again send wall records to another standby, and so on. Well, and interesting feature, you can use delayed replication. You can set up a replay delay in your recovery conf file. In this case, standby server will collect wall records, but it won't replay them until this time. So in this case, backup goes behind your primary server by specified amount of time. For example, you can have standby that is 1 hour behind your primary server. So if on primary some user drops very important table, you can always use your standby at least for 1 hour until this whole record is not replayed on it. Well, and logical replication in Postgres works on publisher-subscriber model. So we have no primary and replica, we just have publisher and subscriber. And one server might publish changes in one table, and other servers can subscribe, and at the same moment other services can publish their changes and our server can subscribe to them, so it can be bidirectional replication. In case of logical replication, we replicate not all records but changed data rows. For example, if you update some row in a table, changed row will be sent to subscriber over replication protocol. When you use logical replication, you have basically you have two servers that can perform its own operations. These are read-write servers, both of them. So subscriber can do something with table, and at the same moment you can get changes from another server to this table. And in this case, it may end in conflict, because you can insert row with some primary key, and row with the same primary key can come from publisher. In this case, replication stops, and you have to manually resolve this conflict. For example, you have to delete conflicting row, and then replication will continue to operate. There is no automatic conflict resolution yet, but we have pgLogical extension. It is made by Second Quadrant company, and in pgLogical they already have automatic conflict resolution. There are several methods for them. So if you need something more complicated than standard logical replication, you can use pgLogical. Yeah.
Really, thank you to everybody who survived these 2 days. You know what, we are not so. I know. I have another some stuff to do downstairs. First of all, really thank you to Egor, okay, for coming, for making such amazing book and materials, and to provide, actually to contribute his time for us. I think this is the most important thing, that actually the guy is not at home, yeah, while actually two of his bosses is downstairs, so you understand, yes, he actually could be somewhere else. we would like, we thought about how we can, maybe not to celebrate, but maybe to sign this activity for, for you, that you also will remember that, but then we too. So we decided to do something like that. I hope it will, you will like it. So let's, Joel Kinan. Yeah, thank you very much. בוא נסתלם. נכון, צודק, לגמרי, צודקים. אוקיי, ג'ואל. יונתן רובינשטיין.
יונתן למטה.
אוקיי, אולגה כץ. מרק ישראל. קובי אהרון. אוקיי. Thank you very much.
Thank you, Igor.
Thank you. Israel Glickman. Okay. Iran Grossman. Okay. No, Ari Friedman.
תודה.
תודה. נרי שטרן.
תודה.
סטאס. Oops. Yaniv Mishan, he's downstairs, yes?
Yes, downstairs.
Maybe you will bring him. Vitaly. Frank.
Thank you.
Thank you. Kaizor. Jack. No, it was nice meeting you.
Excellent. Thank you very much. Thank you. Спасибо, we say.
Mark. Nikita was here. Okay, Avihai Dan, he is downstairs also. Yes? Avihai. So, Avi, you there?
כן. תודה רבה.
תודה שבאת.
Thank you.
Okay, and Denise. I really hope that this course brought you something, okay?
A lot.
You'll talk about any additional courses that you have, yes, that you have. Okay, you can some really brief introduction. So once again, it was nice meeting you all. Okay, we tried to do the best we could. I think we succeeded. Any feedback, welcome. Okay?
בקיצור זה היה בסדר גמור.
תודה רבה. תודה. או, ניקיטה. או. תעודה של ניקיטה, שם.
תודה.
תמונה של כולם, לא רוצה? יאללה, תמונה של כולם. רוצים? יאללה, כן, בוא נעשה. תמונה זה טוב.